Let us consider a situation where variables move in the same direction. When two variables move in the same direction, we call that there is a positive relationship between the two variables, or there is a direct relationship between the two variables. And in this case, when there is a positive relationship, the line would slope upward, and we consider three cases or three examples. In all the three examples, the two variables on the x-axis and the y-axis are positively related, but there is a difference in terms of the slope. So let's consider first case. Say you have speed in miles per hour and the distance you travel in 2 hours span, right? If you are traveling at a faster speed, of course you will be covering more number of miles. Not only that, but you will have a perfectly positive relationship no matter whether you are traveling at the speed of 20 or you're traveling at the speed of 60, right? So there is a positive relationship between the speed and the distance. And not only that, there is a perfectly positive and linear relationship between the two variables. The second case, say on the horizontal axis, we consider distance sprinted in terms of yards and how much time you take to recover. And there will be a positive relationship between the two because the more yards you cover or more yards you run, it's going to take you longer to recover, right? However, when you travel a distance yards of say 5 more yards, it's going to take less amount of time to recover as compared to say you have already covered say 200 yards and you do another 205. The amount of recovery time is going to be much more than when you have covered less number of yards in terms of distance. All right. So the relationship is not only positive, but at the same time it becomes more steep as you move upward with the curve. The third case, say we have study time on the horizontal axis and the number of problems worked on the vertical axis. What would you expect? You would expect the more time you spend on studying economic problems, you would be able to solve more number of problems, right? Makes sense. So there is a positive relationship between the two variables, but at the same time, the relationship is not only positive, but the slope becomes much more flatter as you move forward. And the idea being when you study for say another 1 hour, when you have already studied for just say 2 hours, then the amount of problems you solve will be far more greater than compared to you study for another 1 hour and you have already studied for 5 hours. So you already studied for 5 hours and you study 1 more hour, the amount of problems worked will be far less compared to the amount of problems worked when you have only studied for say 2 hours or less than that. Right? So these are the three cases where you have positive relationship, but the slopes differ. Now consider a situation where variables would move in the opposite direction. When the variables move in the opposite direction, we call the relationship between the two variables as negative, or there is an inverse relationship between the two variables. The line in this situation would slope downward on a graph. You have say 4 hours total to that you spend on playing sport, and either you could play tennis or you could play football, right? So the amount of time you would play tennis is on the horizontal axis, the amount of time you play football is on the vertical axis, and you would expect that if there is a fixed amount of time that you could play a sport, then there is a negative relationship between the two variables, which is the time you play tennis and the time you play football. Not only the relationship will be negative, but there will be a perfectly negative relationship between the two variables, no matter at what point on the curve you stand. So whether the 20 minutes you sacrifice in playing football, you would get 20 more minutes to play tennis, and that holds true even if you are playing a lot of tennis and you sacrifice 20 minutes of playing a football, you would gain the exact same 20 minutes even if you are playing a lot of tennis. All right, so that's the first case where you have a negative relationship, and the important point, the slope is constant, and or there is a linear relationship between the two, linear negative relationship between the two variables. All right, let's say second case. On horizontal axis, let's say we have the amount of the length or of the journey in terms of miles, and the travel cost per mile on the vertical axis. You would expect the relationship between the two variables to be negative. The more distance you cover in a journey, the cost per mile or the travel cost per mile in that journey goes down. So you will have a negative relationship between the two variables. All right. And not only that, the slope will become less steep as you go downward. And the idea being the when you cover an extra mile over here, the drop in cost will be significant compared to when you cover an extra mile at 100 miles. You have already covered 100 miles and you cover one more extra mile. The drop in the cost will be not as much. Okay, so there is a negative relationship, and the slope is less steep as you go downward. The third case where we consider the amount of time you spend on leisure, say for example, and the number of problems you work. When you have, if you are taking say leisure time of 1 hour, an extra 20 minutes is not going to hurt that much in terms of the number of problems being worked. However, if you are taking say 5 hours of break, an extra 20 minutes of break is going to cost you a lot in terms of the numbers of problems worked, right? So you not only have a negative relationship in this case, but at the same time, the slope becomes more steep as you go downward.